Okay, so on Monday we're going to be learning about the Chatelier's principle. Now, just a quick review on what equilibrium is. Remember, when we have a reversible reaction, we have a reaction in which we have the reactants and they are forming products, and then in the forward direction, and then in the reverse direction, we can have ammonia, two ammonia ions which can collide and create our reactants. So when we are at equilibrium, I'll show you this picture again. When we first add N2 and H2, and that's at the very beginning of the reaction, at time 0, we have no ammonia. Now this dark blue line is ammonia, and we have 0 of it at 0 seconds. Now as this reaction proceeds, as the forward reaction occurs, because there is no ammonia, we can't go this way, so we only have the forward reaction. Our concentration of our reactants is going to decrease, and the concentration of our products is going to increase. So the forward reaction is going forward, then we're keep going forward, and then eventually we get to this point where we reach equilibrium, in which the rate of the forward reaction equals the rate of the reverse direction. So that at that point, the concentration of our reactants and our products becomes constant. It does not change because this reaction is going forward and this reaction is going this way, so we've become at a constant equilibrium. Now, the Chatelier's principle states that if we apply stress to a system that is at equilibrium, the system will shift direction to the direction that will relieve that stress. So, for example, if we add any change, when I'm talking about stress, I am talking about any change in concentration, temperature, or pressure. So if I change the concentration of here, it'll either go this way or it'll go this way. So, the very first one is change in concentration. Now, I think on your notes packet, there's a typo and it says increase in concentration shifts equilibrium away from the stress. And then number 2, it says reducing concentration shifts equilibriums towards stress. And I think on your note packet it says shifts away from the stress, but it should be towards, not away. So again, when we're increasing the concentration, what we're really doing is we're adding something. Let me just, sorry, writing on this pen is kind of difficult. Okay, add, we're going to go away. Now, what this means, I think on your note packet we're going to add hydrogen gas. So if we're adding some of this stuff, how I want you to show your work is I want you to circle whatever stress we're applying. So if we're adding hydrogen gas, I want you to circle that we're doing that, and then we're adding some, so I'll put a little bit plus sign. Now, if we're going to shift away from that stress, what's really going to happen is we want to get away from H2. So the forward reaction is going to occur. And we're going to get less N2, and we're going to get more ammonia. So this is how you'd show the Chatelier's principle. If we're going to add stress, I want you to show whatever stress that is. So if we're adding increasing the concentration of H2, circle H2, maybe put a little plus sign. And if we're going to go away from that stress, we're going to get less N2, and we're going to get more ammonia. Now, the exact opposite is if we take ammonia gas away. Now, when we're reducing concentration, that's like taking. So take towards. We go towards the stress. So if we're going to take ammonia gas away, I want you to circle this. We're taking it away so there's less of it. So all of a sudden, if there's less of this, there's going to be more of this stuff, and it's going to want to go in the forward reaction again. So if we're going in the forward reaction, we're going to get less of here and less of here. Yeah. So the next stress is temperature. Now, when we increase the temperature, we're going to shift away from the equilibrium. So again, adding heat will be shifting away from that heat. So remember, when we have exothermic and endothermic reactions. So in an exothermic reaction, it's a reaction that releases heat. Now, if it's releasing heat, the heat is going to be on the product side. So in this reaction, we have an exothermic reaction. The heat is on the right-hand side of the problem. So if we're adding heat, it's really kind of the same thing with increasing the concentration. We're going to add heat. So if we're adding heat, this reaction is going to want to go this way. We're wanting to go away from the stress, and we're going to get less of this and more of this and more of this. I really need to practice with this pen a little bit more. Okay, so now if we're going to reduce the temperature, we're going to take heat away. Then we're going to go towards the stress. So we're going to take this heat away. Take that away. We're going to go towards the stress, so we want to go in the forward reaction, and we're going to get more of this. We're going to get less of this and less of this. Pressure. Now, remember, with pressure is really talking about volume. Remember from our gas chapter in which we talked about how if we had a container, and if we made that container smaller, our gas all of a sudden would have less less space to move around in, and therefore there'd be more collisions against the wall, and the pressure would increase. So if we're increasing the pressure, what we're really doing is decreasing the volume. Okay, so if we're going to be increasing the pressure or decreasing the volume, we're going to be shifting to the side with less moles of gas. So, as we can see right here, we have 1 mole of gas of N2 plus 3 moles of gas from hydrogen. So on our reactants, we have 4 moles of gas. Now on our reactant side, we only have 2 moles of gas. So if we increase the pressure, we're going to shift to the side with less moles of gas. Now again, if I ask you, I think on number C1, I ask you if we're going to decrease the volume. So if we're decreasing the volume, we're increasing the pressure. So if we're increasing the pressure, we're going to shift to the side with less moles of gas. We're going to be shifting this way. Now, when I'm talking about pressure, we can't really circle one of these three because we're not really the stress isn't really applied to exactly this one or this one or this one. So when it's relating about pressure or volume, what I really want you to do is somewhere near these double arrows put a V and either put the volume is going down or the volume is going up or the pressure is going up or the P is going down, whatever one. So again, if we're making our volume go down, our pressure is going to increase, so we're going to shift to the side with less moles of gas, so we're going to go in the forward reaction and we're going to get more ammonia and less hydrogen and less nitrogen. Now the last one, decreasing the pressure shifts equilibrium to the side with more moles of gas. So we're going to decrease the pressure in this one. So if we're decreasing the pressure, our volume must be getting bigger. So we're going to take P, reduce it, and that means we're going to increase the volume, or pressure decreasing, so that means we're going to shift the side with more moles of gas, so we're going to shift in the reverse reaction, which means we get less of this, more of this, and more of this. Okay, so this is what we're going to be doing tomorrow. We're going to be going over some worksheets, and we're going to be spending a lot of time practicing this stuff, so come tomorrow prepared, and if you have questions on this stuff, make sure you come and ask me. Alright, I'll see you on Monday.